Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure session called the tree top view. And for this particular challenge, given a pointer to the root of a binary tree, print the top view of the binary tree. The tree as seen from the top of the nodes is called from the top view of the tree. For example, right here we have the node 1 as the root and node 2 as the right side of the node 1 or the right property, and then we have 5 and then we have 6 all on the right property, and then we have the left subtree or the left branch of the node 5. We have 3 and 4, and the top view which is only 1, 2, 5 and 6, and 3 and 4 is not being counted and recognized as the answer. And complete the function of the top view and print the resulting values on a single line separated by space. And we have a function of the public static void which is not expecting anything, hence the name void right here. And we have the function called the top view which takes one parameter called the root in the form of node custom class that already declared right here on the commented section. And we are using Java as our language. If you want to use something else other than Java 7, then go ahead and encourage you to do so. And for the constraint right here, we have at least one node in our tree composition, and the maximum nodes are 500 total of nodes, and the output format which is print the values on a single line separated by space. Just on the sample output right here, we have 1 on the root, 2, 5 and 6. 3 is not being counted because 3 is below the 2 and it's on the shade of the 2, below the shade of 2, and also 4 is below the shade of 5. So let me visualize this by drawing something. Let's say we have a node in the highlighter. We have a node of 1, 2, 5 and then 6 divided by the chain of the node, and we have the node 3 and then node 4. If you look over from the top view, we have the top view from the above the root node right here, which is 1, and if we draw a line, then we have the answer of 1, 2, 5 and 6. And if you notice, after the 2, which is 3 right here, 3 is not being considered as the answer because 3 is under the shade of 2, and 4 is also under the shade of 5. So let me visualize this as the top view. Imagine it is a sunshine that shines through the roof, which is roof number 1, 2, 5 and 6. Under the roof of 2 we have the 3 which is on the column, and under the roof of 5 we have the column of 4. So anything under the node already hit by the sunshine is not being considered as the answer. And 1, 2, 5 and 6, which is the surface roof, that is being counted. Let me draw something again. We have the sunshine that shines through from the top view, and we have node 1, 2, 3 and 4 and then 5, 6, 7. So 1 is being counted because it is the surface of the roof, which is the peak of the roof, and 5 is also being counted, 6, 7 also being counted, and 4 is also being counted because the sunshine hits the surface of the roof. 2 right here is also being considered, and 1 also being considered, 5, 6 and 7. And we return the answer as 4, 3, 2, 1, 5, 6 and 7. And anything that under the, let's say we have the right property of the node 2, which is 3 is not being counted at all from the set because it is under the roof of 1, and 3 is considered the inner part of the surface, so it's not being counted. So the same thing also goes to the node 5 right here. We have the not right property but the left property, which is 7. Let's say it is 7, and the right property is 6. 6 is being counted as the top view and the 7 is not, is because 7 stands below the node 1 right here, below the node 1, and we can declare our sunshine with the coordinate. So we can declare this as the coordinate of 0 and then coordinate of 1 that shines through the line of view, which is 5 right here, as the view. And we have node 6 which shine using the +2 right here as the coordinates, and we have +3 that shines through the node 7 right here as the surface roof, and we declare this as the sunshine that glares through the roof, and this is the surface of the roof. And that is the rough explanation. And anything up below the 0, which is considered a -1, and then -2, and then -3, and so on and so forth. -1 shines through the node 2 right here, and the -2 or the -2 shines through the node 3 right here, and the -3 shines through the node 4 right here. And why we should declare our coordinate as the sunshine is because we need to return from the left side to the middle part, which is the root right here, which is the parent, which is node 1, and up to the point to the right part. So that is the order of the answer. We have 4, 3, 2, 1, 5, 6, and 7. So that is why we are using the coordinate as the sunshine. So that is the rough explanation. Let's implement this. We have the top view function, and we can do using the approach of creating a class called the Q object. We can declare a class, another class inside the function itself again called the Q object, and inside of the class we can declare a node which is the node that from the custom class right here. We can declare the node as the node, that is the name of the property, and we have declared the second property, which is in a form of integer called the coordinates using the coord. And for the constructor itself, we can construct our Q object that takes 2 parameters. The first one, which is the node, data type of node, and the second parameter, which is the integer itself of the coordinates, integer coordinates. And for the constructor right here, we can declare a this node is equals to the node that takes from the first parameter and will be assigned as the property of the node of the class constructor. And then for the next one, we can declare this dot coord of the coordinate and takes the second parameter as the coord, so that will be assigned from the second parameter as the property of the class of each parameter as its property. And it is denoted by the yellow underline. It's because we haven't used it yet. And for the next one, we can use a class, but before declaring a class, we need to declare our Q object to define our linked list. So as we traverse over the linked list using the algorithm called the BFS, or the breadth first search, and that way we are iterating over from the parent root to the right side, which is +1 and then +2, to check, and then checking if after we declare on every pointer right here on that iteration, which is we are currently on the 5, and checking 3 and 6 will be assigned and 3 will not be assigned, is because the 2 already assigned as the +1 and the 3 is not being assigned. It is on the +1, it is also on the +1, but then +1 is already occupied by the node 2 right here, which is on the surface roof. So let's declare a Q, or the Q variable, or the storage, which is that takes a data type of the Q object from the class that we already declared from earlier, and we can name this as the Q, and then equals, we need to construct new linked list, and we can declare the linked list type of the Q object. Why we are using the linked list instead of, wait a moment, let me continue the music, the background music. You cannot hear from this video because I'm disabling it. Okay, so let's continue again where we left off. Oh, it is on the linked list. On the linked list right here, why we should declare a linked list with the data type of the queue object that consists of the everything of the queue as the queue object class. It's because linked list is better than using the array. Let's say after the iteration or certain iteration that we need to remove the queue right here, if we, let's say we happen to use array from the array of consists of 1 to 5 and then 6. Let's say if we happen to move 1 from the first array, then of course we need to reference or to shift anything behind the node or the data 1 to right here, which is on the index 1, and 5 on the index 2, and 6 on the index 3. Let's say 1 is on index 0, 2 is on index 1, 5 is on index 2, and 6 on the index 3. Let's say if we happen to remove the first part of the array, which is the first element right here, which is 1, and we have to readjust our value 2 from the index 1 to the index 0, and 5 from the index 2 to the index 1, and also 6 from the index 3 to the index 2. So that is a lot of work to do if we happen to have a lot of values inside the array. So if we use the linked list, we can just remove the first one. Let's say we are removing the one right here from our linked list data, and then it only reference on the next value without even referencing on the which index is it from on the node 2 right here using the linked list, or the data 5 or the data 6. After we remove 1, the 2, 5, and 6 and the rest of the linked list data of the queue object will not be shifted to the left. And also the same thing if we happen to remove the last element, which is 6 right here, 2 and 5 will not move. So that is more effective than using the array. And the queue, we can use a method called the add and polling. Add is adding to the right side, which is the at the end of the composition. And for the poll method, we can simply remove the first one and then reference the next one after the first one has been removed as the next poll if we happen to trigger the poll method. So let's declare another variable called the map that takes two key value pair of the integer, and we declare a map called the map and construct new TreeMap that consists of key value pair, key of integer, and the value of integer. And that way we are storing the first one, which is the key, which is the coordinates from the coordinates right here from the queue object class, and the next one will be the data of the node. We have the data of the node of 1, and if we happen to store this inside the map, the node 1 right here will be stored as the key value pair of the current coordinate, which is this one is on the root, which automatically assigns as the 0 or the coordinate of 0, like I already described from earlier of the sunshine visualization and the surface of the roof. And the node 1 right here, which stays at the root, it is always on the coordinate of 0. So anything below the root will be on the right side will be added by 1, or if it is on the left will be subtracted by the 1. And 1 right here stands on the coordinates 0, and 1 will be assigned as the data, as the value right here, and the key, which stands for the sunshine coordinate, and the 1 right here as the node itself, which is the peak of the surface roof. And also on the node 2 right here, you guess it, using the key value pair of 1, which is on the +1, and then the 2, which is the data itself, we can assign 2 as our map. And for the next one, which is on the coordinate 2, we have the value of 5. And the last one, which is we have coordinate of 3 plus 3, and we have the data value of 6 extracted from the node right here. And that way we can return this as our answer. And you might ask me about the TreeMap specifically that I use. The TreeMap, we explicitly declares a TreeMap as the constructor type better than map or hash map is because TreeMap will automatically sorts the key as our answer because as stated right here, we need to declare from the left surface of the root to the point to the right surface of the root. Let's say we only have 1, 2, 5, and 6, and there is nothing more on the left node of the 1. So 1 will be considered as the leftmost side of the map surface roof, and we iterate over the 1, 2, 5, and 6 of the keys from the 0, 1, 2, and 3. So in short, TreeMap will sorting all of the key from the least value to the most value, which is on the 0 right here, which is the least value, and 1, 2, and then 3. If we happen to use hash map or just map, we will get the value, not the value but the key, but it is unsorted. Like 1 will be placed right here, key 1, and the value of 2 will be placed on the front. It may be that the 0 right here, key of 0 will place on the right side of the composition of the map variable right here. So we use the TreeMap to automatically sort the key value pair from the map variable and to make it much more easier to implement. Okay, so the next one, we need to declare a QAdd as our initial operation. QAdd, we have the add method, and we added the another Q data as our new linked list added to the end of the QAdd, the latest element of the queue, the end of the queue. Is in the QAdd. Inside of the QAdd, we can declare a new constructor, new queue object of the class, queue object class. And for the class constructor right here, from the constructor that we already described, the node itself, we can declare the node as the root derived from the parameter of the root right here of the first function call of the top view. And the coordinate, we can declare a coordinate as the integer of 0. Remember that we are starting from the index 0 from the parent node, as I described or as I visualize on the sunshine and roof, sunshine that shines through the surface of a roof. Okay, so the next one, we need to operate the queue by using a while loop. As long as the queue is not empty, is in the isEmpty method, because isEmpty is supposed to return a boolean. Check if it is either true or false, since it is checking using the exclamation mark in front of it, checking if it is not empty. As long as the queue is not empty, we need to remove the first part of the queue, is in declaring a new queue object variable called the object, and then we can declare a queue method of the poll method. A poll method will return the first element of the queue if we have any. If we don't have any element inside the queue variable, then we will return null if this queue is empty. From stated as the method right here, it is stated as this, and it is a bit different than using the remove. Let's say from the Java 7 documentation right here, we have both remove and poll. They are both doing the same thing. Remove. Where's the remove? Let me see it again. Yes, we have poll right here, and poll will retrieve and remove the head of the queue or returns null if the queue is already empty. And we have the variable called the queue, and it is a bit different from the remove method. It does the same thing and retrieves and removes the head of the queue. We have the, let's say if we have the first element of the queue, we will return the first element and removes it from the queue variable, and then supply it as the object variable, and will be supplied as the object variable from the remove first element using the either poll or remove. But the remove will return exception, no such element exception, if the queue is already empty. So that is the distinct difference between using the remove and poll. So for this challenge, I'm going to use poll instead of the remove because it is much more easier. And we can add a check if if the map does not contains any key, using the contains key of the object dot coordinates. We are accessing the object itself from the queue poll or the poll queue, or the remove from the first element, which is the root and 0 right here, and the coord. We are extracting the coordinates to check if the map does not contains any key of the reference key as the coordinates from the sunshine, from the coordinate 0 right here. Since 1 has already declared as the data from the coordinate 0, then if check will not triggers. If the map has not been added as the key 0 right here as the coordinates, then 1 will be inserted as the map variable. We need to assign the map.put, and we assign the object dot coordinate as the key, and the value we can assign the object dot node and then dot data. Why I'm using the node is because the node right here, which is from the queue object custom class, and we are accessing the node of 1 right here because the node has the property of the data right here, and we are accessing the data property, which is 1, and we are assigning as the 1 as the value and the 0 as the coordinates or as the key. And for the next one, we need to declare another if check if the object dot node dot left is not equals to null, and that way we are checking if the left side of the of the polled object is not null, to check if it is existing. If it exists, then we need to add this to the queue by using the queue.add, and we declare a new constructor of the queue object, which is the node of the object node, of course using the left property. Assigning the left property because we are checking if the left is not null, then we need to assign the left. Oh, it is not null, then we need to assign the left from the derived object of the node, and then dot left property. And for the coordinates, we need to declare from the initial coordinates of the 0, since it is going to the left part of the roof of the surface of the roof, then we need to use the coordinates -1 subtracted by 1 using the coordinates. But for these coordinates, we need to declare this in front of the coordinates. We cannot just declare coordinates as it is, and we need to access it from the derived object from the poll method using the object dot coordinate and then -1, since object coordinate already declares as 0, and then using the -1 we will get -1, and then we assign the object node left as the left part, and we assign the coordinates as the -1. And we can do the same thing as the right side of the object using object node.right to check if the right side is not null, since on the first test case we are having the right property of the 2 right here as the node 2. Since it is not null, then we need to assign the 2 as the node 2 as the +1 using the queue add new constructor of the queue object. The first thing should be the object dot node dot right, and then the coordinate we use the object dot coordinate, but since it is going to the left side of the roof, then we can declare the coordinate as +1. And finally, after everything has been completed, we need to declare a for loop that declares and iterates over the every key from the list 1, which is from the all of the negative values up to the point to the most positive values. Since it is stated as the coordinates, then it is much more easier, and we can declare this from the key value pair of the map variable right here, using the declare an entry using the for of loop. If we are using the JavaScript for of loop for every entry inside the map.entrySet method, and that way we are iterating every entry of the key inside of the entry set. And don't forget to declare the type using the map.entry and the first data type, which is the key of the integer, and the second data type, which is also integer, which is denoting by the data property of every entry inside the map variable right here. Since they are both integer, the key that states the coordinates, and the second one, which is the data of every node that we already traverse into. So for the next one, inside the for loop, we need to use the System.out.println, not printline but printf specifically, and the first parameter is in the printf with the print and format method, and we can declare the first parameter as the formatting of the debug println, and using the percentage and then d, which is denoting as the digits, and comma the second parameters, which is the entry of the get value using the get value method. And that way we are assigning the entry.get value, we are assigning the every value from the entry.get value method, and we are assigning this on the second parameter as the one on the percentage d right here, which is the digit, and then added by this space separated integer as stated from this statement right here. Complete the function top view and print the resulting values on a single line separated by space. And that way we are iterating over the from the for loop right here for the map entry. We have using the entry right here, which is entry of like this is entries, and the first one, which is the key, and the second, which is the value, and we are iterating every value, only the value, from the left side to the right side. We are printing 1, 2, 5 and 6, hence the name get value right here, get value method. So let's run the code to see if it works, and we have the correct answer from the first example only, or the first test case. Let's submit this code to see if it really works. Okay, it looks like everything is already completed, and let me declare another visualization using the screenshot right here. Let's say if we have the case of, let's say we have node 1 right here, and the next one we have the node 2, node 3, all on the left side, and then for the node 2 we have the left property of 4, and then the left property of 5, and then the left, not the left but the right property of 6, and we have the left property of 4, which is 1, and then 2 on the right property, and on the left property, which is 0. Okay, so for the, let's say this is the roof constructed roof surface, and this is the sunshine, and this sunshine shines through the root, which is the node 1 right here, denoted as the 0, and the -1 will shine through the surface of the 2, but not on the node 1 right here. And we have the -1, or the -1, that is the -1 as the key, and the 2 as the value, that is the key value pair, and then the -2, which paired as the value of 3, and then 0 is not being counted because 3 already blocks the sunshine from the -2. And for the +1, we have the sunshine shines through the node 5 right here, but not anything below the 5. And the +2, we have 2 as the key and 6 as the value pair. So the returning answer since we are using the TreeMap, we are returning the 3, 2, 1, 5, and 6. So that is considered the top view, and 4 is not being counted as the coordinates 0 because it is already blocked by the roof of 1 or the parent root. So 2 is also not being counted at all. It's already blocked by the 1 right here. Is because the TreeMap is only returning the distinct value or the unique value, even though the node 4 right here, which is stated as the 0 and 4 as the key value pair, and then 2 right here, which is stated as the 0 and 2 as the key value pair, because 1 is already described as the 0 and then 1 as the unique key value pair. So that is the neat use of using the map, or especially TreeMap, because we are arranged from the 3, 2, 1, 5, and 6. So the returning answer will be 3, 2, 1, 5, and 6, and not the 4, not 2, and not 0, or even 1. Remember, from the left to the right part of the surface of the roof. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.